tell something before so all people. Okay, let the people join, so it will take time. Meanwhile, I will tell this story. Okay, so I'm using this packet tracer to create a small network, or maybe I can create a very big network also. Okay, I can create in a physical location manners also. Okay, so like that is I can create a things like this is a New York office, this is India office, this is my hometown office, like that. I can create in the network in the manner of like that, or I can simply see the logical diagram wise only. Okay, so this is a search. Actually, it is a manageable search. Okay, it means we can able to configure this search. Can able to configure search, but I'm not doing anything. You see this MAC address table of this particular switch. What is the content in the MAC address table? Nothing is there. Are you able to see? What happened? Are you able to see the content here?
Yes, sir.
Okay. It's not showing any MAC addresses or a port numbers also. Okay. So here it is. What I'm doing is, so first of all, these systems does not have an IP address. So I'm configuring an IP address. So I'm configuring 192.168.1.11. When I press the tab button, see, automatically there is a subnet mask is appear. I'm not configuring any other things. You can see I'm not configuring default gateway. I'm not configuring any DNS address, only IP address and the subnet mask. And I'm using default subnet mask. And this is the class C IP address. Same goes for other devices. Okay. And I must configure in the same network. In the same network means this is class 3. First 3 portions are a network portions. Remaining is this part is host portion. See, that's it is common for everyone. It's the class C. First 3 portions are same, must be same in the class C. See, it is I have given an IP addresses. I want to see once more. Yeah, it is auto discovering time. It means whenever I assign an IP address, it will do some packet network discovery type. Okay. So what it is done, it is a MAC address and this is the port number 1. And it is not in a proper order, but because of the first identity, based on that it is created. And it is dynamic. Dynamically, the switch is learn. I didn't enter anything into the switch. It is dynamically switch is learn about a MAC address of connected device. Can you see this is FPA 0 by 1 port. This is 0 by 1 port. And this is that PC. Okay, so I'm going to the, sorry, not a terminal, command prompt, get MAC. Is working. Okay, not working. ipconfig /r. So can you see this MAC address 000 to 17DE99ED? Okay. And where is this part? Is it same or different? You want to see side by side? Side by side. See the highlighted? See the highlighted one. Both are same or different? Of course, this is small letter, this is cap letters. Oh. Guys, are you able to see anything? Are you able to hear?
Yes, sir.
Yes, sir.
Then I ask one question. If you don't understand, I'll ask it's the starting first starting time only, right? If it is at 12 o'clock, 1 o'clock, you are exhausted, then I can understand. Can you able to read this? What I highlighted? IP address. Okay, it's a what it is MAC address of the PC, which is connected to the port number 1 in the switch. And is these both are the same or different MAC addresses?
Hello, is I'm audible, sir?
Yeah, you're audible.
Yeah, sir. That should be same.
Very good. Very good. Okay, that's my point. If you see, this is the this PC is connected to the port number. 1 second. It is 2. Okay, for a switch, it is a port number 2. You can, if you want, you can like this. It is a port number 2. Okay, and in a here, where is the port number 2 here? And this is the MAC address is landed by switch. But is it really or not? We will see. This is that PC1. Okay, go to terminal, IP config. Sure. This is the MAC address of that our second PC. Okay, 00E0 8FC4 E20D. It's the same. Both are same, right? Port number 2, it is showing a MAC address. Whose MAC address it is? This particular PC it is. And their IP address it is. Okay.
Sir, I have one question. Like the screen is not clear. Sir, the ports is FA02 or FE02? Ports.
FA.
Like here,
Like this.
FA. Okay, sir,
It
what's
means
the meaning
fast
of
Ethernet.
FA?
FA means fast Ethernet. Like this is a
FE.
switch.
Acha. Yeah, I got it. I thought FE should be. Okay.
No.
Okay. FA. Okay.
Fast.
Okay.
FAST, right? So like that. Okay.
Okay.
Like this. These are the ports. Totally 24 ports will be there. And 2 additional ports with the gigabit port. These are the fast Ethernet, means 100 Mbps ports. Okay.
And for gigabit, what they called?
Gigabit ports are GA something it will come. So
Okay.
1 second will.
So 100 Mbps in what sense?
100 Mbps up to 100 Mbps data transmission it will support. Fast.
Okay. Okay.
So guys understand that's the MAC address table, and whenever we connect, so the certain switches already I told based on the certain switches and based on certain systems what it will do. So immediately we'll try to recognize it. Sometimes it is in a world switches type, so it will learn when it is you are communicating from here to here. it will try to learn and then it put it into the MAC address table. That is the point. Okay. Of course, it is a small letters. And here it is. Just think like it is a oral session kind of stuff. Okay. So 2-3 points I will add it. So first is I want to show the MAC address table. And what switch will do? Using this MAC address table, it unique cast the packets, right? If I want to send a packet from here to here, okay. If I want to send a packet from here to here, so what will happen? It will directly go to this one only instead of sending to all other devices, connected devices. So that is also we can able to see from here using a simulation. Using a small simulation. Guys, this is called a packet. I click on this packet here and I click on here. So you see from here to here, it has to be reached. Okay. And it is a simulation mode. So I have to go to check step by step how packets are going on. So the packet went to the switch. Okay. Packet went to the switch. And of course, it done a broadcast. So why need a broadcast? It is already, it is there. And it is giving reply. So I have to show you the step by step. Now it is finally reached. It is not required that much. Again, 1 second, we'll go to this. Okay, switch from here to here. See the packet once again. So it is PC0 and PC2 is a destination. Source is PC0, destination is PC2. And layer 3. So can you see these are the OSA layers, 7 layers. What is layer 3 contains? Source IP address 1.11. Destination IP address 1.18. Okay. It is using ICMP means ping request only. Okay. And layer 2. It know the destination MAC address. That's what it is showing. So source MAC address and this is destination MAC address. When I click this one step, so what will happen here? So in the layers, it is see where is the IP address here? Because this will only take care of IP address. Which port number? Which port number? See port number 1, PC0. Port number 3, PC3, based on the MAC address table. Next. So it is not broadcasting this time. First time it is broadcasted. Second time it is not broadcasting. Okay. So finally, so again, it reached to the system. It is not showing any kind of port number kind of. So it is so source IP, destination. Source MAC address, destination MAC address, and it is reverse. Now it is going to reply. Okay, outer layer. Then it is reverse. Source IP, destination IP, source MAC address, destination MAC. Yeah, someone is asking question. Tell me.
Sir, I wanted to know what topic you just started with because I joined a little late.
I started actually, we seen the hub and switch differences, right? Okay,
You
switch.
were showing something related, MAC address related something, I think. Right
Yeah.
Before.
So you didn't study the switch part again. Hub, switches, routers, modem. We discussed it in
Yes,
previous classes, right? I told you what is the difference between hub and switch.
Yes, sir.
Yeah, what is the switch specialty compared to hub? Switch can able to learn MAC address of connected devices. Switch unicast the packets to the destination based on the MAC address table. Switch create a MAC address table. Using the MAC address table, it will able to send packet to the destination.
And so this this packet tracer you are using, like we also have to know how to simulate this, or you are just showing this to make us understand?
Yeah, just for our understanding purpose. Okay.
Okay, sir.
Okay. Not only switch one, I'm going to show you small things. Like a last class we discussed about an IP addresses. Okay. So that also I'm going to show you that one. Okay. So it's a small practical like. Okay. Just for our clarity purpose, observations purpose. Okay. I got one question. Maybe if you are observed, that is, I showed already MAC address table. Okay. I showed already a MAC address table. Again, I will try once again. Now it is only come to the two. Okay. Now all. Actually, it should be created like this. It is because of first only it is learn, but because of these transactions, it learned two MAC addresses only. One is port number 1 connected devices, another one is port number 3 connected device, because both are communicated each other. Okay. Even though there is a MAC address table, or maybe it is changed now. So whatsoever it is, the first time it is broadcasted, next time it is not broadcasting. Okay. First time it is broadcast to everyone. Next time it is unicast. Same simulation. Why? So I will show you that one also. See guys, this is the packet. I click here and I'm going to reach here. So this is first time, right? From here to here. Again, it is first time we are communicating. Okay. First time we are communicating. See the packet contents. Okay. See the packet contents. So what is the source? PC1. Destination is a broadcast. I told destination is this one. But what will happen here? It is, see the source IP address 1.12. Destination is 1.14. This is the destination 1.14. This is source 1.12. And source MAC address is this one. This is this PC MAC address is this one. What about destination MAC address? Not given correctly. It is given all Fs. Because very first time you are communicating to the destination, you know the destination IP, but your system don't know destination MAC address. Understand? When you are communicating in the day or maybe after a fresh start of the system, okay, maybe a first start of the system, okay, and maybe that is the first time you are communicating from A to B. A has an IP address, B has an IP address. A has a MAC address and B has a MAC address, right? But when you are sending a packet from A to B, and you will send with a source IP, destination IP, source MAC address, and destination MAC address. Of course, we are purposefully set with an IP address, so you know the source IP address, it is A's IP address. You know the destination IP address, that is a B's IP address. And from it is starting here, it means it know the source MAC address means A's MAC address. But you didn't mention anywhere about a B's MAC address. Did you mention? We didn't mention. We mentioned B's IP address, but we didn't mention B's MAC address. Okay. So I will show you that one also. For example, oh, we are in a simulation mode. Okay. Well, we can cancel the simulation mode. We'll go to real time. See, here it is. This is my first PC. So I'm trying to communicate. Ping 192.168. Mine is 11, so I'm going to communicate it to 1.13. Okay. You mentioned about a destination. I'm 11 and you are mentioned about a destination. Okay. So you are able to ping. Of course, that is a good thing. But did you mention the destination MAC address here? Understand the question? If you don't know, no problem. Answer is you don't know, no problem. But important is where did you mention the MAC address of destination here when you are sending a packet? Just understand the question.
So can you explain again?
Okay, no problem. That is no problem. You are communicating from one PC to another PC. Simple, a test command called a ping command. Okay. So how you test it? How you send a packet with the ping command? So ping destination IP address, right? What you will do? Ping destination IP address. It means B's IP address only you type. Maybe other means of communication is there. For example, one system to another system, other means of communication, like sending messages or maybe accessing a website if it is a web server. So only we use IP address to communicate and we use the destination IP address, right? We use a destination IP address. But while you are communicating from one device to another device in your local network, in local LAN network, the packet contains totally 4 addresses. What are there? Your source IP address, destination IP address, because from your ARP starting, you have a source IP, and here you have to reach destination IP. From here you are started, it means you know the source MAC address. But this system does not know about a B's MAC address, right? You have your own IP and MAC. You don't have a other system MAC address. So I have to put a B's MAC address. But here I didn't mention, I don't know what is the B's MAC address. I didn't mention anywhere. No need to know answer. But do you understand the question or not?
Yes, sir. But we can find B's MAC address, na?
But
Like
again, you have
NS
to go to
lookup,
B. Yeah.
NS lookup, NS lookup, NS lookup.
NS lookup, that is a different command. Okay.
So I can like scan whole the subnet. Then I can find the B MAC address.
How? How
Like
this system knows? How this system knows B's MAC address?
like they are in same network. Like I'm assuming they are in same network.
Yeah, same network.
Same network, same subnet. So
Same
when I scan the whole subnet /24, so I will get the MAC address because it will give me where is the what you call where is the location of the B. If B is not a mobile phone changes the MAC address randomly. But if B is a PC, then it will give me the MAC address.
Very good. I think you mistook a concept of MAC address. MAC address never change. Either it is laptop, desktop, mobile phone, tablet, or any kind of.
Sir, if you want, I can give you the screenshot. Latest Android have randomized MAC address.
Why?
Because of security. I don't know. Yes, it give us a headache. Like
That is
where's
called
the
spoofing.
you,
The real
yeah
MAC address never
that's
change.
the physical address. That's never changed. But the spoofing is always like in the software, like in the software thing, you can change every time.
Yeah, that is called spoofing. Okay, don't go to the spoofing part. Okay,
Sure,
think
sure.
normally.
Okay, sure.
So then you will, are you understand the concept or not? Then you will get it. Point.
Yes.
Okay. So first of all, MAC address is fixed on NIC. It is there. Okay. So simple concept is, so I'm not asking how you get it. I'm asking simple. Do you understand the question is, when I'm sending a packet, means I'm accessing remote system using SSH or a telnet or web related. So different ways of communication is there. But on any type of communication it is, we mentioned about a destination IP address only, right?
Yes, sir. Sir,
Mm.
can I say one thing?
Yeah, tell me.
Sorry, sir. It's not NS lookup. It's nmap. Sorry, my bad. I was confused with
Yeah,
host
map.
domain name.
Okay.
Yeah. And nmap minus s, capital S minus u, then n. So it will give me the whole subnet
क्यों आए हो?
like.
एसी में बैठना नहीं है आपको, है? मासा को यहाँ गर्मी में लग रही है, गर्मी में बैठी है मासा.
Oh, not Linux. Okay.
Not
Ah,
okay.
okay. Linux, yeah. Most
Okay,
of the
it's
time.
okay. It's okay. So
Sorry, my
leave
bad.
it like that. Okay, I will tell the answer. Okay, so don't worry. But understand what I'm trying to say the concept. So do you understand this part? First part, what I said, when I'm communicating to my destination system, either using ping command or maybe I am using something like SSH or maybe a telnet like a remote access or DP access or maybe web related communication or FTP communication it is. Okay. So when I'm communicating, I will mention about the destination IP address. That point you got it?
Yes, sir.
I didn't mention about the MAC address of the destination because I don't know I don't know the MAC address of destination. I need to other tools to scan it. That's a different point. You are not mentioning about MAC address anyway. You will find it, but you are not mentioning about a destination MAC address in the communication while you are communicating to other device in the same local network. Any network, so you don't mention any MAC address. But when you are communicating any communication, so there is a 4 addresses are there. One is source IP, that is from your system. You are starting anyway, you know your source IP. Source MAC address from your system, it is starting. The packet is traveling from your system means it know the source MAC address. Destination IP, that is you mentioned destination IP. What about the destination MAC address? We don't know the packet. When packet is constructing, it does not know the MAC address of destination. It does not know. Actually, for a very first time you are communicating. That too, your very first time you are communicating. Maybe after a fresh start of the system, or maybe in an entire network, that is your first time you are communicating. In generally by default, I'm saying by default. Maybe in another things it can be there, but by default, this MAC address is you didn't mention and your system does not know about the destination MAC address. So what system will do it? The point is, what system will do it? It use a MAC broadcaster. It is contains 12 Fs. Okay, instead of destination MAC address, because it does not know the destination MAC address, what it will do, it use the broadcast address, MAC broadcast address. That is a 12 Fs. That's the point I'm trying to say. Got the point now? You have a source IP, destination IP, source MAC address, and destination MAC address as a MAC broadcaster. Okay.
Understood.
Okay, that's the point. Okay. The very first time you are communicating, so what happened? Your packets it shows. Okay, F like that. It is I sure no. So like that. Once again, we'll see the packet. So not like this. It is escape. Okay. Go to the simulation mode. And from this to this point, we never communicated till now. Okay. from here to here, we didn't communicate. See, we are starting from here, and we are already communicated. Then it is a problem. Then there is a problem. We already done a communication means there is a problem. Because it knows the destination MAC address. Okay. Of course, it is useless right now. Okay. I'll take one more system. So just for a fresh start type of thing, I'll take one more system and I'm going to connect. This is the cables. Just I'm trying to explain the ARP protocol. So, and then it is given a big 192.168. 1 dot, this is 11, 12, 13, 14, 15. This is the fresh system. Okay. This is 15 system. It is connected to 5. From here, again, I'm trying to communicate it to this one using simulation mode. Now it is green color. I will try once from here to here. Okay. Now 2 packets. Can you see? Here it is. So source IP and destination IP address is there. Not showing any layer 2 type. Okay. Only layer 1 address is only showing it is. The first step I'm doing. So the packet went to the switch. So I'm again, we'll see. Can you see this? Source MAC address, source IP, destination IP, source MAC address. Can you see the destination MAC address? Guys, can you see the destination MAC address?
Yes, sir.
What is the destination MAC address?
He said अरे कहाँ गया? नहीं हाँ उसके ऊपर हाँ सर वही.
Okay. The destination MAC address is, as I said, it use a broadcast address. Okay. And your switches does not know which is actually your destination. Why? Because of you don't tell what is your destination MAC address. You are telling about my destination MAC address is broadcast address. Your switches does not know, even though there is a MAC table. So what it will do? First time, so what it will do? It broadcasts to everyone. So the packet is meant for whom? This PC only. Remaining PCs will drop the packet and it is received by this packet. And what is this PC is received? The packet content plus source IP from here, this PC IP address, this PC MAC address. Okay, so it will be received at here. Okay, so remember that point. What I said. So I use a broadcast to send it, but at here, can you see? So when I'm sending it, I use MAC broadcast. But this is a replying message. Means what is the source IP? 1.15. Destination is 1.12. And this is source MAC address, means this PC MAC address. And this PC MAC address is this one. See the here it is source MAC address. Here is a destination MAC address. Both are same. Look at here. Okay, this is a source MAC address, and this is the destination MAC address here. When you are sending from this C1 to this C4, right? So the source MAC address is this one. And here it is C4 to C1. What is the destination MAC address? Is C1's MAC address. And here is destination MAC address, broadcast address. I don't know C4's. But here it is source MAC address is C4's. Why? Because itself there is a machine. Okay. Understand, guys? I send because I don't know this PC MAC address. Now I broadcast it to everyone. And these are all drop the packet and it accept the packet and it is get ready with the reply packet. In the reply packet, okay, in the reply packet, it contains this PC IP address and this PC MAC address, this PC IP address, this PC MAC address. Understand that point, guys? Can I explain again? Can you just to look at the addresses, guys? You will understand. It is very simple concept. It is. Someone sending a message. Okay. Tell me. Oh. Again, people are stop talking. This concept understand, not understand. Have to go.
Sir, can you explain this again?
Very good. So in the first part, I told I am sending a fresh packet. These are the fresh systems. When I'm sending it, I don't know the destination MAC address, but finally the packet is reached to the BSPC. And when it is received, it checks, is it a IP address is belongs to me or not? Then it accept the packet. Once it is accept the packet, it is ready to reply. Okay. So when it is replying, so again, what is the source IP? From here it is starting. What is the source IP? B's IP address. What is the source MAC address? B's MAC address. B's because this PC knows its MAC address, right? What is the destination IP? Of course, because it is send an IP address. So that is the destination IP address. What is the destination MAC address here? Is MAC address. Destination IP address, MAC address is A's MAC address. Why not broadcast address? So if you see this packet, can you see this packet here? It shows destination IP address 1.15, destination, sorry, source IP address 1.15, destination IP address 1.12, and source MAC address and destination MAC address. And it is telling this is a destination MAC address. Instead of using broadcast. How this system knows the destination MAC address of this PC1 while replying packet. Understand the question, you understand the answer, don't require. Okay. So how it is understand this MAC address, how it is A's MAC address we got it because we sent it. We sent this entire information here, right? So it contains A's MAC address, which is belongs to this A's IP address. Because you are sending that A's MAC address to the B, so the B stores that information when it is replying, or maybe when it is communicating again next time, it use that one. If you use this IP, automatically gain this MAC address. That is, understand, guys?
Sir, the MAC address stores the information, right? I wanted to understand the difference between the IP addresses, significance of IP addresses and MAC addresses. Like both have IP, destination IP and source
Yes.
IP, and both have destination MAC address and
Yes.
source MAC address. So
Both
I,
sides we have source IP, destination IP address, source MAC address, destination MAC address is there. Yeah. Next, ask me. So something you're telling.
like I wanted to, what is the importance of MAC and like what is the importance of IP? IP is just a route, right? And a MAC is on in the system.
IP, of course, that is the point you said, correct. IP within the LAN, and there is no logical division. So when you are communicating one to another device, you communicate with your IP address as well as a MAC address also. But actually, you mention always with an IP address. MAC address will follows with the packet. You don't mention anywhere in a MAC address. And second thing is, the MAC address also an important factor because only the physical part, connectivity part only. Okay, within a packet only. But originally, you can identify the destination with an IP address only, not with a MAC address. And of course, for you making more unique, more security purpose or uniqueness purpose, more uniqueness purpose, or unique casting purposes, and as well as allow a specific device or deny the specific device to connect or to communicate also, we can able to do with a MAC address. Okay. So as you guys are told, so recent Android versions, we can spoof our MAC address. It means you can communicate with other devices. When you are communicating, you can communicate with a different MAC address than actual MAC address. Someone is trying to block actually your MAC address, but still you can use another MAC address to communicate. Okay, it's not just like that. Okay, so there is a things are there. Okay. Yeah, so guys, we'll continue the simulation. So here it is a packet. So we've seen the packet. This is the outgoing packet of from PC from here to here. Okay, the simulation starts. So from here to there. So the packet went to the switch again. And yes, this is the packet. There is clear source IP, destination IP, source MAC address, destination MAC address. Next step, so finally packet is reached. So it is a check mark means finally packet is reached. Okay, packet is reached. Understand up to here? The first time when we started packet from here to here, it done a broadcast. Remember that point. Okay. So now see again, I'm doing same thing. This is second time I'm communicating from same PC1 to PC4. Same PC1 to PC4. This is second time I'm communicating. First time I communicated. This is second time I'm communicating. So packet went to switch and packet went to PC4. Why it is not broadcast?
Because switch already have the addresses.
So I'm going one more step back. Source IP, destination IP 12. It is started. Destination is 15. What is the source MAC address? This destination MAC address. First time we seen, before that also first time we seen the destination MAC address is all are Fs only. But now it is destination MAC address it is showing. What happened? Why it is showing destination MAC address? Now that it went to the switch, in switch it will tell this is my destination MAC address In the switch MAC address table, it shows. So what is the it's locked now. You cannot use it because it's in simulation mode. In switch, there is a MAC address table. It compares where is the destination MAC address and what is their port number. And next, it reaches the destination. It is the destination. Now packet is ready to give the reply and replies and reaches here. What happened? First time it is broadcast, next time it is not broadcasting. Okay, understand that part. That's enough. It's not required more. First time it do broadcast, second time it is not broadcasting. Understand that part or not? That's only the point, not everything. Again, people are silent. So guys, first time you are sending, that time you don't know what is the destination MAC address, right? First time you know, right? Yeah. So what you done for destination MAC address, instead of destination MAC address, what you use? A broadcast MAC address. And the packet has to send to everyone because so we don't have any destination. There is no broadcast means to whom it is switched on now. So it will tell to everyone. The packet went to finally reach B. B system receives based on the understanding of IP address. And it stores this A's IP address and A's MAC address into a table. In a specific table, it is there inside a B system. It stores this A's IP address and A's MAC address. That is called a ARP table. Address Resolution Protocol. It maps to your IP address to MAC address. Destination IP address to MAC address. Means A's IP and A's MAC address stores in this ARP. Once the B received a packet, so it in the packet it contains A's IP, A's MAC address. So what BPC is doing? It put into the table. It stores that information in the ARP table. Next, what B is done? It send a reply packet to the A. So when B see the communication, in that only I'm telling. So when it is sending, so it need a source IP, right? So what is source IP? BIP. It has its own MAC address like this. And destination IP, it knows, of course. And destination MAC address, instead of MAC broadcast, it using A's MAC address. How? Because it is in the table. Now, this information sent to A. And A receives this entire information. What A is doing is B IP address and B's MAC address stores in the APC in a ARP table.
Sir, what happened when we store a IP address and a MAC address? What after that?
Yeah, it will store. That's it. Okay. And when it is communicating, what is the next? What is the importance of storing? Right. So what is the importance of storing? When these devices are communicating with a specific IP address, like a B IP address, A again it is want to communicate it to B. Second time, we communicated second time, right? So when it is sending a packet, so it has to be added an IP addresses. A IP address, B IP address, A's MAC address. Now it is not required to broadcast. Why? Because of from this table, it knows B's MAC address. Now it is able to send unicast away. It know the B's MAC address, then it is went to the search, switch check for the which port it is and unicast. Understand guys, ARP table. So when any system received a packet from a device, it creates in a ARP table, it stores that received packet contain IP address and MAC address. So when B received a packet from A, it stored A's IP address and A's MAC address in the ARP table. So that's why when it is communicating again to the A, it's not required to broadcast. It is simply knows A's MAC address from the ARP table. Same thing for next time A is communicating to B. So when A is received a packet from B, it stores B's MAC IP address and B's MAC address in ARP table. So when A is communicating to B, now it is not required to B's broadcast MAC address is not required. It use B's MAC address as a destination. How it is? From the ARP table. Okay. Understand the importance of ARP table. I will show you that ARP table, don't worry. See, it is. Oh, nothing is working. Okay. It's a simulation type, right? So ARP space -A, it is showing because it is already communicated to the 1.13 system. This is 1.13 and there physical machine 11, 12, 13. This is a 13 machine and this machine MAC address and this machine IP address. It is there in the ARP table. So this is PC0. Okay. And this is the PC1. So we'll see ARP space -A. It two times it is communicated. One, it is communicated to the PC3 1.14 and also it is communicated to 1.15. From that PCs, when it is received a packet, the ARP packets. So when it is received a packet from the PC3 and PC4, the PC1 stores their IP address and MAC address. So next time it is communicating from the PC1 to these devices, next time it is communicating, it use this MAC address directly. That is a ARP address resolution protocol. And this is ARP table. This is the one we used, right? So I will show you this ARP space -A. So from 12 PC, we got it. We got a packet. This PC got a packet from 12 PC and 12 PCs MAC address. For example, from here, I am giving an IP, a ping. Okay, from here, I am giving a ping. Ping from PC0, 1.11. I am giving ping from 1.11 to 1.15. This is 1.15. See the 1.15 ARP table. Okay, from 1.11, I am giving a ping request to the 1.15. Okay, I send a ping request. It means packet went to the from here to here. Packet will went and you will get a reply. So what I am going to do is I am going to 1.15 and check ARP table. Now I got this information. See earlier this information is not there. Now it is added. Why? Because of I received a packet from here to here. Okay, then I record that information. Okay. Okay, when I given this packet from here to here and this PC add one more information, that is 1.11 and 1.11's MAC address table. And here also, when we are send a packet, also we'll we'll get a reply, right? So here also 1.15's MAC address also you can find in the ARP table. So where is this is 0. We send a packet. See this, we send a ping. So ping means two-way communication, send and receive is there. The 15's PC MAC address. What is ARP? Address Resolution Protocol. It maps IP address to MAC address of destination systems. So when a device learned a packet, so whenever a device received a packet, it learned the IP address in that packet, IP address and MAC address in the packet, and that information stored in the ARP table. Whenever our system is communicating to that device, what it will use? So when it is communicating to that device, okay, so it use that IP address. We are communicating with IP address, and it from the ARP table, so it can able to get that IP addresses related MAC address. Okay, that is the point I'm trying to say from starting. Guys, that information is not here. So that information is I'm going to add separately. ARP. What is ARP? Address address I think still people are in a school mode, some are in the college mode only. So you should not speak kind of people. Okay, guys, it's not like that. You have to speak. If you speak, you get more attentive. So it's like you given a lot of beautiful questions and answers. That is more important. That is the way of learning what you are done earlier. So like you are asking questions, that kind of stuff. That is what I want to get it because of this when this HCL training is started from last 2-3 years, I'm continuously giving. People are always keep silent. So I am almost all like I speaking to all type of one. If someone is asking question also, I should give an answer. I have to think about it like that. Okay, better. If you speak, I can explain much better. If you don't speak,
Okay.
you will sleep. I will sleep. It is the only thing happens. Not only for you guys, me also. Online classes means listening is very difficult. In online, listening is very difficult. It's like if someone is speaking and we'll sleep, right?
Oh, yes, sir.
Uh, that's what I'm trying to. That's why today I try to push like this to people. So whether you know, don't know, so it does not mean you. Even it is that is completely out of your concept. Like you may not hear earlier, but so that's you will be start thinking what you are learning. Otherwise, you will forget. If you don't think, you will forget. Generally. Okay. That's what I'm trying to say.
Okay, sir.
Very good. Address resolution protocol. When a system or device received a package. Yeah, tell me.
Sir, I wanted to ask that both systems and switch, both all the system and switch maintain an ARP table by themselves.
No. Actually, switch does not maintain ARP table. In general, as you know, but you will have to check it once. In case your modern switches are enabled, show ARP. That's it. Not showing any ARPs. Yeah, of course. The switch is also maintain the ARP table, but only thing is switch ports does not have any IP addresses by default. It does not have any IP addresses kind of stuff. Okay, so in case you configured a VLAN type of configurations, VLAN virtual LANs configuration you have done on the switches, so then you may have a ARP tables kind of stuff. Like a if you are assigned like if you have a level 3 switches, maybe you may contains ARP tables level 3, because level 3 it contains a IP address protocol inside. Okay, VLANs having a level 3 protocols means IP address kind of concept is there. Okay, but in a level 2 only MAC address, no IP address. In that cases it won't show. Okay. If you ask me, I will tell like that. If I ask Sai processor is actually worked with a layer 3 switches on. So then he will tell there is a ARP table. But ARP table in a level 3 protocol means IP address is also there. Okay. So L3 switches, or maybe in a L2 switches also, if you are having a VLAN enabled with an IP address configured, so it may shows ARP tables. Okay. In generally, our systems are direct devices which actually we have an IP address. So this is we can able to applicable directly. When a system or device received a packet which contains addresses of source, IP, destination, address, source MAC, destination, source IP, destination IP, so access, the system or device learn the destination, sorry, IP address and MAC address of received packet. Means not ours, not to address, from address, not a to address, from address. You got a simple guys. You received a letter. It contains to address, from address. You know your to address, so you keep it aside. But you want to send it back, you want to reply it. So what you will do it? You save the from address, right? So same thing like that. It save the from address. The system or a device learn the IP address, MAC address of a received packet. Received packets, systems, received packets system or device, and and store into ARP table. Okay. ARP table maps IP address to the MAC address. IP addresses to MAC address. So simple. You get a like hyphen is enough. Okay. It contains what is a ARP table contains IP address and MAC address. Whose the destination related means the remote related. When the system or device communicates to the remote system device like remote PC, remote server, remote system, it use this ARP table to communicate. Table for getting MAC address to the remote IP address of the remote device. I written very big sentence just for reference purpose only, but I told a big story that is very useful story, guys. Okay, even myself, you can see I'm going to my command prompt. So ARP space hyphen A. Okay, it shows so many things based on my IP address. See, this is my IP address, my system IP address, and these are the different IP addresses and their MAC addresses. Okay, their MAC address. So for example, I am communicating to this IP address. So I don't need to mention the destination MAC address. So it will get it from the here. If I'm communicating to this one or this one or this one or this one, so I'm not required to mention the MAC address. Of course, I'm not mentioning it. Okay, I'm not mentioning it. But the point is, it get the MAC address from this ARP table. But after this, I will trying to communicate a system which is not in this list. What will happen? It use MAC broadcast. But when it is reply, it got a reply from the destination system, it stores here. Okay, it is only based on the local network. It works only in the local network only. It's not related to any WAN kind of stuff. But it's up to here. This is a point. This is my local IP address, and these are the different devices in my network and their MAC addresses. How I got it? So when it is communicating to that device, it learn the MAC address and it put it into the ARP table. Oh, not this one. I want this one. Okay, guys, this is about ARP address resolution. What is this dynamic? What is this dynamic? Because the system learn the MAC addresses of received packets from a system dynamically. So you can Okay, so there is a thing like CMD. There is a thing like IP address. A means display all, and D means delete. S means statically you can add it. Okay, so this is we can add ARP record statically. Okay, this is for displaying purpose. This is for adding a things. Hyphen D is for delete records or entries. Hyphen D. ARP. Okay. So what is the use of this statically adding? This is dynamic learning. This is statically we are adding it. What is the use of adding ARP information statically? Anybody guess? Either between the systems, computers, or anything, routers kind of stuff also you can do that one. Any idea? So why we can able to mention statically is it can able to learn dynamically, it is good. But why? What is the use of mentioning statically? Any guesses? No, following guys. Guess it. So then you will understand better. So I mentioned in this PC a static entries like a PC1 IP address and their MAC address. Statically, I'm adding 2, then their MAC address, 3, their MAC address. In every device, I'm adding these entries. What is the advantage? What is the disadvantage? Last point, I will give you a break.
So it will take more time.
Tell me.
It will take more time.
Yeah. If you have more systems, every device you are adding, it will take a lot of time. Really, that is horrible. Right? Maybe if it is a for very first time, that is like okay, but every time like 100 computers are there, 100 times you have to add both source and MAC address. It's very difficult. That is NATO. Very good. Tell me why it is advantage wise. Security. In a certain secure environments means there is a limited systems. Maybe there is a main administrator system and there is a server and there is a certain systems only there. Only few very secure environment, not a regular securities. In a highly secure environment, so you have to mention manually that is in every system. In one system, you have to tell about in this system, you have to tell about this system IP address, MAC address, this system IP address, MAC address, this system IP address and MAC address in this system. And you can able to configure in the IPsec configure if IP and MAC matches communicate. IP and MAC address in an in and out packet means incoming packet and outgoing packet. If both IP address and MAC address matches, accept the packet or send the packet or receive the packet. Otherwise, drop the packet. Understand, guys? You received a packet and you have ARP table
Yes, sir. Yes.
and you verify it. Received packet IP address, MAC address match with your ARP table. Accept it. Otherwise, drop the packet. Okay. So, and you need to learn dynamically. So even dynamically learning also someone in the network, if in case someone in the network create a MAC spoofing kind of stuff. Means their IP address is one and another is different MAC address. They try to spoof the MAC address way so they can get some packet to at their system. So to avoid this kind of spoofings, avoiding internet spoofing kind of stuff or attacking kind of stuff, to make it tightly secure, we can use this ARP bindings, and that we will apply into the security layers also from layer 3 to layer 4, layer 5. So we can able to apply. So this is one of the reason. And this same concept also used for your Wi-Fi MAC bindings. Like you mentioned, allow these MAC addresses if MAC address is in the list and give the Wi-Fi connectivity. Otherwise, don't give an Wi-Fi connectivity. Okay, like these bindings are understanding of bindings is very important, of course, and main concept is about an ARP address resolution protocol. And what is the process when a packet is received? Then that is the PC will learn the IP address and MAC address of the MAC address in the PC, not it's from the destination, from address, from the remote system, whatever the packet is received. So it learn the IP address and MAC address and put it into a table called a ARP table. That is called a address resolution protocol. And what is the advantage? When it is communicating again to that remote PC, so it's not required to do the MAC broadcast. It will get the MAC address from here and directly you can able to use the unicast type of communication. Understand, guys, this part? So actually, we have to discuss about IP address, subnet mask kind of stuff. Actually, we started here, but we have to continue from there. Take a 10 minutes of break, guys. I think it is okay. Just I'm stop recording. Don't go anywhere. I have to take a